Hi, my name is Anthony Bernaco, and this is my Excel report. As you can see on my first scenario here, we have our body movements and our miles per hour and our table that we created under the solar system and the local group. We have our formulas here, and under our total, we have the formula that we use to sum up the whole thing. Under here we have our pie graph that we use that we created. I just dollied it up a little bit. Over here, my screen is so much bigger because I use dual monitors. Sorry. You can see the Earth's rotation is minimal. That's why it's 0%. Shows on the graph. The Earth's orbit, 67,000, shows as 1%, and etc. Moving on to the report. Before I even knew what the scenario was, I had chosen planet Earth. Just because it's one of the most amazing planets, in the universe. Just going through, our calculations are based for the Earth's rotation are based on somebody standing on the equator. There's less speed to the north and more to the south. Also, the time of the year relative to the summer and winter solstice would also play a factor in the tilt of the Earth. So we use the calculations at the equator for the Earth's rotation because it's a little bit more constant than the other locations. A system of measurement that we use that can be used would be binary code. It's something that we can use to measure multiple things. The computer uses it to measure. Let me see what I wrote here. It uses it to convert the number one or a color, and it's just a series of ones and zeros. Scientific notation is an easier way for us to express very large or very small numbers. When written by hand, we use the digit we're expanding or contracting multiplied by 10 to either a positive power for a positive integer or a negative power for a negative integer. And then another way for calculators or Excel to read scientific notation is 1e plus the number, or 1e negative. Okay, let's move on to scenario number 2. Here's the Earth there. In scenario number 2, we use the unemployment rate percentages of the Clinton and Bush years. During Clinton, it was 5.2052%, and Bush was 5.1%, 5.1852. Here we represented each one in a bar graph. Um, these two graphs are different because they have different starting points. So it can show how the misrepresentation of data is evident by the starting points on the graph. And that's basically the theme here in this scenario. Same thing with the average bowler scores. You know, we got Diana, Hilda, and Emily. Same thing. Now it looks like Emily's that much higher, but in all reality, they're pretty close together. Moving right along. Okay, we have the contributors for the arena funding. With the snippet here, shows the graphic shows 265 million from the city. The graphic shows 50%, where in reality they donated 65%. You know, and it's just a this is just misrepresenting the actual numbers. Moving along, to the Quartera graphic. The percent in sales in the company. Quartera's got itself in this center donut at 4.5%, and all the other companies along the outer ring. We did our circumference and our area, or our radius in our area, and we found out that the center of the circle is 15%. So not 4.5% as they want to appear to be. So the 4.5% is actually a lot less than what they trying to show, I think is what I'm trying to say. Here's another graphic. If they were put into a pie chart, they would have the smallest sliver. So they're just trying to misguide the viewer into thinking that they contributed more than they actually did. But you can see the formulas here. That's the area of the circle. And that's the area of the smaller one, I believe. And then we divided the two to come up with that number. So the scenario 2 report, simply put, a politician may not have come out of a survey favorably. So misleading information and misdirection would help hide the truth of that data. You know, and this whole scenario is just about misleading and misdirecting and bad data, and starting points. So the best thing to do is to just pay attention to where your starting points and the graphics are that you see. Scooting along to scenario 3, we have our Venn diagram with our table, with our numbers of Americans in millions, and we have our total number of Americans here. Obesity, type 2 diabetes, high blood pressure, type 2 diabetes, and obesity. All the different, and these are the percent in Americans. Some of these numbers were given to us, some we had to formulate. But you can see the overlapping where 16.1% people have high blood pressure and obesity, but only 0.9% of people have obesity and type 2 diabetes. And this is the probability of Americans to have it is 63.2%. Now the numbers of Americans in millions, 10 million Americans are obese. 3.1 million Americans that are obese also have type 2 diabetes. 27.7 million have all three. So, may not be completely related, but these ailments seem to feed off of one another. I myself have pre-diabetic symptoms that run in my family that come just from hereditary. So, moving along to number 4. This is where we have our heights of our Army recruits and the heights of our mall shoppers. We have our scatter charts with our trend lines. We have our box and whisker charts. We have our range, our median, mean, with our formulas. So we're looking at all the ranges of the heights of the Army recruits. Same thing with the mall shoppers. We can see that the Army recruits are all close to the same height, where there's more of a there's more vary in the heights of the mall shoppers, where one being close to 3 foot tall, and there's just more of a chance for some randomness in a shopping mall than in Army recruits. Um, so the standard deviation in the Army recruits is much less than the standard deviation of the shoppers. Um, the coefficient of variation is larger in the mall shoppers than than the Army recruits. So move along. Scenario 5. We have our sleep study with our mean and our standard deviation. And here's our here's uh, our median sleep is 6.7 hours. And then as it goes up, we have our formulas. And our standard deviation, as you can see, goes down. And obviously we don't have the negative sleep, but as you can see on the graph, the standard deviation is 34.1%. I fall into the second one. I get about 8 hours of sleep a night. I'm old and I go to bed early. And there's that, and here's all the data that we used. To come up with that. Here's the snippet of the household incomes with the outliers and the high income households skewing the mean from the average, skewing the mean from the median, and creating this rat tail down here. Then the last the last scenario is the profit according to sales of Elon Musk's flamethrowers. We have our little parabola here. Put my little stars on it so you can see where he started out. I tried to color coordinate it. So it started out at, its profit started out at negative 12,000, which started out right here. at 100, selling at 100 flamethrowers. He was at just about negative 70,000, which is right here on our graph. Um, he right here is about where he he started to turn his first profit at about 203 flamethrowers. Is the math that we did, and then his final big push was up here at around 260 to 300. He started making his big profit. My name's Anthony Bernacco, and that's my Excel report.